You just saw a demonstration where we dropped a piece of paper and a baseball at the same time. Now, we crumpled up that piece of paper, and when we did, the baseball and the piece of paper hit the ground at the same time. Now, I kind of tricked you a little bit there, right? Before the demonstration, I had the piece of paper just laid out flat and said which one's going to hit first. Everybody said the ball was going to hit first. Intuitively, you know when I drop a flat piece of paper and a baseball at the same time, the baseball will accelerate down toward the ground quicker. But when I crumple up the piece of paper so that it's more or less the same shape as the baseball, and air resistance becomes a lot less significant or a lot less important, at some level we all know that they're going to hit at the same time, and we just saw them hit at effectively the same time. This is the point that I want to make. In the absence of air resistance, in other words, if air resistance is not a significant factor, you're in a vacuum. You drop something on the moon, it doesn't matter how heavy it is, the object will accelerate downward at 9.81 meters per second squared. Now, when I had the piece of paper just laid out flat, air resistance was a lot more significant because surface area increases air resistance. Mass actually decreases air resistance. So that baseball would have, even when the piece of paper was crumpled up, the baseball would have had slightly less air resistance than the piece of paper, but the surface area was a bigger factor. So when I crumpled up the piece of paper, that it was almost the same air resistance as the baseball, which meant that they both accelerated downward at essentially the same rate, which was negative 9.81. Can anybody suggest to me why I say negative 9.81 as opposed to positive 9.81? It speeds up at 9.81, right? Yeah. Yeah. It's speeding up, it's accelerating, but it's accelerating downward in the negative direction. In the absence of air resistance, all objects that are falling experience an acceleration of negative 9.81. But in the absence of air resistance, if there is no air resistance, then all objects that are rising also experience an acceleration of negative 9.81. How do you explain that one for me? Okay, we just had a pretty good explanation. A couple hands went up there, actually. Pretty good explanation as to why when the baseball was falling, the acceleration was negative 9.81. But why is it negative 9.81 when it's rising? Well, when it's falling, it speeds up in the downward direction. It speeds up in the negative direction. When it's rising, it slows down in the positive direction. So in general, we say that anytime, any acceleration, particularly gravity, whenever we're speeding up in the negative direction or slowing down in the positive direction, either one of those result in a negative acceleration. At the risk of talking about something from our next unit, which I don't really want to do too much, but I'm going to just briefly mention it here. What causes the ball to speed up going downward? Gravity, right? The force. I said we weren't going to talk about forces this unit. I lied. I'm going to talk about it for about 30 seconds here. The force of gravity pulls down on the ball to make it speed up. What causes the ball to slow down as it's thrown up into the air? The force of gravity that's pulling the ball down. So a downward force causes it to speed up going downward. A downward force causes it to slow down when it goes upward. A downward force is a negative force, which gives us a negative acceleration in both cases. You're going to solve some problems today involving gravity. Now, how are these problems different than the problems that you've been solving over the last week of class? Not much different at all, actually. The one thing that separates what you've been doing from what we're doing starting today is that we always have the value of acceleration given to us, even if it doesn't say it in the question. If the object, the baseball, the whatever it is that's falling or rising has no air resistance, then the acceleration will always be negative 9.81 meters per second squared. Sometimes in other questions that you've been doing over the last week, the acceleration has been given to us. Always the acceleration is given to us now, as long as there's no other forces other than gravity acting. Got it? Same equations apply. We just have the value of an acceleration. Here's a question that's in your textbook. Example 1.17 on page 57, that's chapter 1. You always know which chapter it is, right? Because example 1.17 means look in chapter 1 for it. Page 57, it says, while cliff diving in Mexico, a diver throws a smooth, round rock straight down with an initial speed of 4 meters per second. The rock takes 2.5 seconds to land in the water. How high is the cliff? All right, what do we got here in this question? What do we got? What is this 2.5 seconds? Yeah, that's the time, right. What is this 4.00 meters per second? We'll call that the initial velocity, all right? Somebody might say the final velocity is 0. No, it isn't. After you hit the water will slow you down and stop you. You will be moving at 0 meters per second after the water stops you, but the final velocity at the end of the fall isn't 0. You're moving when you hit the water, right? Like, you are moving. If you jump from, this high up, and you, like for instance, keep your arms out, it hurts. Like you could literally break your arms or separate your shoulders. And that's, gentlemen, and that's not because your velocity is 0. It's because your velocity is not 0. It hurts because you're moving when you hit the water, right? Because VF is not 0. So VI is 4 meters per second. VF is not 0. We don't know what that is. Anything else that we have here, if we read between the lines a little bit? What is it? Acceleration is what? Good. Acceleration is negative 9.81 meters per second squared. By the way, sometimes we'll call that A. Sometimes we call it, since it's gravity, sometimes you might call it G. Doesn't really matter. Either one of those would work, okay? I'm going to call it A. We're looking for how high is the cliff. We're looking for the displacement, basically, right? How far this rock has fallen during that time. Is that all right? Any errors there? There is one. I let you make it. But I gave you the slightest little hint. Oh, it's a subtle little hint as to what that mistake was when I wrote this down. The subtle little hint as to what the mistake is, I left a space somewhere. I left a space, a little bit of a space right here for me to write something in there. Yeah? Yeah. It's thrown down at 4 meters per second, right? So VI is negative 4.0 meters per second. Does that make sense? Left a space so we'd have room to write in the negative. Okay, looking for D. Group A or Group B? It's Group B. Which Group B do you want to use? Pick one. Yeah. Yeah, I think that's going to work for us. D is equal to VIT plus 1/2 AT squared. VI is negative 4. T is 2.5. And 2.5 again squared. Let's do this on the calculator here. Let's say negative 4 times 2.5. We get, for that first term, negative 10. And for the second term, we get 0.5 times negative 9.81 times 2.5 squared. Negative 30.65625. Now let's add those up. We get negative 40.65625. Now we should round that, right? How many digits should we round it to? This is 3 digits. This is 3 digits. Final answer should be 3 digits. Negative 40.7 meters. Wait a second. The height of this cliff can't be negative 40.7 meters. The displacement of the rock is negative 40.7. The rock has fallen 40.7, right? What's the height of the cliff? 40.7, right? So if you wrote that down as your answer, I would accept that. I wouldn't take off marks for that. But technically, the initial height of the cliff should be positive 40.7 meters because the rock has fallen 40.7. Its displacement is negative 40.7, but the height is still positive. Does that make sense? Either one of those I'd take, though. Please take a look at these 3 questions on page 58. Number 2 says, having scored a touchdown, a football player spikes the ball in the end zone. If the ball was thrown down with an initial velocity of 2 meters per second from a height of 1.75 meters, how long is it in the air for? This is a tricky question. If we write down our givens here, we say VI would be negative 2.0 meters per second, negative because it's thrown downward. We'd also say that the acceleration is negative 9.81 meters per second squared. And we'd say that the displacement is negative 1.75 meters. Everything's negative because everything's going down. We're looking for t here. Now, the equation that we want to use for this, that we're tempted to use for this, is d is equal to vi t plus 1/2 at squared. How many people looked at that equation and said, yeah, I think that's the one? Yeah, that's a perfectly valid equation. The problem with that one is that t that we're looking for appears in 2 places. How do you solve for that? Well, most of you guys, a lot of you guys probably can't do that. How many of you guys remember from math class something called the quadratic equation? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Some of you guys haven't even done that in math class yet. Some of you have. If you've done it, the quadratic equation can be used to solve for t there. If you haven't, then you have no hope of solving for t with this equation. So I'm going to do it as if we haven't learned the quadratic equation, because some of you haven't, and I'm not going to teach it to you here. So what I'm going to do is, in this question, pick another equation. Maybe vf squared is equal to vi squared plus 2ad. What's that going to get me? Do I have vi, a, and d? Yeah, I do. I'm not looking for vf, but that's okay. By the way, how do I solve for vf there? How do I get vf by itself? Square root it. So if you ever find yourself in a bit of a jam, just get something. Even if it's not what you're looking for, get something. And once you get something, then that might make what you're looking for a lot easier to find. That's what's going to happen here. We solve for vf there. It's the square root of vi squared. Oh, I got a question for you. Let's see who can nail this one. Why did I not put the negative in there when I squared the 2? Well, 2 squared is a positive. Negative 2 squared is a positive, but I didn't even put the sign in there for it. What did I sub in? What is this variable? VI. What does it stand for? Tell me what it is in words. No, it's not initial velocity. VI is initial. Somebody said it? Speed. Okay, and what's the initial speed? The initial velocity is negative 2. What's the initial speed? 2. Does that make sense? Speed doesn't have a negative associated with it because it's a scalar. So we're going to say VF is the square root of all that. Let's figure that out. That's going to be 4 plus 2 times neg 9.81 times neg 1.75. Is 34.335. So the square root of 38.335 gives me 6.19. 6.1915. That's the final speed. By the way, the final velocity would be what? 6.19, right? No. The final speed is 6.19. The final velocity is, which way is it going when it's done? Down. The final velocity would be negative 6.1915. Now, is that going to help me to solve for t? Yeah, I think it is. I think it is. I could maybe say, let's try this. There's lots of options now, just like that fake quiz that we did earlier in class, right? Lots of options at this point. Okay, this equation is going to work. Lots of other ones would as well. I'm going to solve for t. Let's get rid of what's, like this whole thing can be considered to be one term. Just take it over by dividing. d over vi plus vf over 2 equals t. So d is negative 1.75. Vi is negative 2.0 plus negative 6.1915. Looks pretty ugly, but works. Let's get what's inside the brackets on the bottom first. Let's say negative 2 plus negative 6.1915. Let's divide that by 2. Now I've got what's inside the brackets. And now let's say negative 1.75 divided by what's inside the brackets on the bottom. Gives me 0.427. What's the answer they have in the book? They have 2 digits, actually. Should it be 2 digits? Yeah, it should actually, right? This is 3 digits. This is 2 digits. Final answer should be technically 2 digits, the least precise piece of data. So technically that should be 0.43 seconds. But like I said, I'd mark that right on a quiz or a test. 0.427 for now at least. Anybody get that number a different way? Nobody used the quadratic equation, did they? No? Anybody get it using a different equation? Could have. Okay. Last question for the day, page 59, 1.18. It says a clown throws a ball upward at 10 meters per second. Find the maximum height the ball reaches and the time that it takes to do that. So what do we got? What do we got given to us here when this clown throws his ball upwards here? What's VI? I don't care about A and B here right now. I'm just going to write down givens for everything, right? What's VI? 10. What's A? The acceleration. Negative 9.81. When it's going up, it's slowing down at 9.81. When it's coming down, it's speeding up at 9.81. So in both cases, it's negative 9.81 meters per second squared. We're looking for the maximum height the ball reaches. And we're also looking for the time that it takes. Is there anything else that we have here? There's something else that we have to have here, otherwise we can't do this question. Yeah? What's VF? Good. When you throw the ball up into the air, okay, I've got a baseball right now in my hand. Let's pretend I'm throwing it up into the air, but I'll do it in kind of slow motion here. Okay, when it goes up into the air, what happens to it as it's moving upward? It slows down. And when it reaches its maximum height, it stops. And then it starts speeding up, going downward again, right? If we're analyzing just the trip up, then VF is 0. It stops. The end of the trip, the top is, we say VF is equal to 0 meters per second. That's critical for us to solve this. Now we can do this. Let's say, I'm going to say, I think for the first one, VF squared is equal to VI squared plus 2AD. Solve for delta D. Get rid of what's not attached. VF squared minus VI squared. Then get rid of what is attached. Take it over by dividing. VF is 0. 0 squared minus 10 squared over 2 times negative 9.81. Let's do the bottom first. 2 times negative 9.81 gives me negative 19.62. 0 squared minus 10 squared on the top. Divided by negative 19.62 gives me a displacement of 5.0968. And it worked out to be positive, which makes sense, right? Because the displacement of the ball as it goes up into the air is up. We're going to round that to 3 digits. Why 3, I hear? Why 3? Well, this is 4, right? So final answer should be 4, right? This is 3. So the final answer should be 3 digits. Here's your homework tonight, guys. The question's on page 59, or the question, I should say, on page 59 that goes along with that.